As we begin this data visualization course, from our needs assessment, it became evident that we have to do a little bit of introduction to statistics so that we get to know some concepts and how to do basic calculations that relates to them when we begin to talk about data visualization. Okay. So a look at our table of contents. We are going to be talking about data and its elements, measures of central tendencies, then measure of dispersion, and then do some exercises. Okay. So for the first part, let's look at data and its elements as we go into defining or trying to decipher what data is. Okay. So data is a collection of facts, a collection of numbers, words, measurements, observation, etc. So as simple as they are, we can say it's a person's name is data. We could also say a person's date of birth or even the day we are today is data. When we collect these data, we begin to want to make sense of what it tells us. And that is why one important part of visualization is storytelling. And we are going to look at that in this course as well. How do we tell stories with data? So data is all around us and is the reason why courses like data analytics or business intelligence basically is selling now more than ever. And that is why you see professionals or the data analytics profession or business intelligence profession, data science, data engineering, and so on. These careers are actually on the rise. The needs for professionals that can handle data, that can work on data, that can analyze data and turn data into insights are on the rise. Okay, because we generate data every day. I'll just basically put it like this. As far as we breathe, as far as we take part in activities, as far as we are alive, we are generating data by the minute. Okay? So now with that understood, we will go into trying to understand types of data. Let's see the types of data. When we get into Python programming, we'll be talking about data types. So, but that is not what I mean here when I mean types of data. We want to see what data as it is. How are they categorized? Okay. So data is categorized into two: qualitative data and quantitative data. We can go further in categorizing this. Okay. For qualitative data, we have nominal data and ordinal data. So I'll be giving examples. Under the nominal data, we have gender, marital status, and employment. But while we look at these examples, we will need to know what even qualitative data is. Qualitative data, as the term qualitative, is non-numeric, okay? This data describes qualities, they describe characteristics. And so you can see with the gender of a person, for instance, marital status, employment status, they describe characteristics or qualities of a person or of a subject, okay? Now, then under qualitative data, we have nominal data as I've showed us, and nominal data now labels variables into categories that cannot be ordered, okay? They cannot be ordered in a meaningful way. For instance, in gender has no order, right? You are either male, female, or you understand? So it doesn't mean that, okay, female must be first, or when you're a female, you are lower than, there's no order. So is marital status. There is no order to this, okay? Okay, so they are usually mutually exclusive. And here we have talked about these examples: gender, marital status, employment. But the reason why we are doing this introductory course is so that we understand when we talk about data, we want to make sure you expand your knowledge so that it is easy for you when you begin to work with data. So we have more examples under nominal data, and that is why we are explaining what nominal data is, okay? Then under ordinal data, we have examples like economic status, level of satisfaction. I will explain deeper. But what is ordinal? What are ordinal data? Ordinal data is a group, or there are groups of variables that are ordered into categories, okay? So they have a natural order or rank, okay? Sometimes they are, or basically they are ordered based on some hierarchical scale. For instance, when you check in the economic status of a people, you can say this person has low economic status. So you know you are categorizing that person as probably having maybe less than $1 a day, or mid-economic or high economic. So you know it's based on hierarchy. So now this clarifies nominal data, right? You know that there is no hierarchy. They are mutually exclusive. Items in between, for instance, gender is mutually exclusive. Marital status, mutually exclusive, okay? So, however, in ordinal data, there is a relation under economic status, for instance, because it's basically classifying a hierarchy, right, or a rank. Then, for satisfaction, when you ask your customers how satisfied are you about this, 0 being not satisfied, 10 being highly satisfied, you see that you can basically see the relationship, right? From not satisfied to satisfied. So you can basically measure that. Then level of education, another example, okay? So you see that someone with no education and someone with the highest level of education, you see that there's a hierarchy in between that. So we have that as ordinal data, okay? When we collect such data, we term such data as ordinal data, okay? So under quantitative data, we have discrete and we have continuous. And then let us describe what discrete data is. Or before we even go about describing what discrete data is, we want to let us know what quantitative data is. Okay? So quantitative data, these are data that can be expressed as numbers. Okay? They are used to measure values or counts. You say this is 5. We have 7 items here. They are quantitative, like basically can count them. They are numbers. Okay. So now under discrete data. So I believe you can hear me very well. So under discrete data, okay, discrete data now represents data or data items that can be counted. They are finite, right? And represent as whole numbers, okay? Let's say they can be divided into smaller parts, okay? Sorry, they can't be divided into smaller parts. I'll give you the reason why. Discrete data can be divided into very small parts. And let me give you examples of discrete data and we'll clarify that. For instance, the number of children in a class or number of goals scored. And since discrete data, that is why sometimes when you say you want to calculate the average number of students and you begin to divide number of students and you say the number of students is 12.5. The funny thing is that what student became 0.5? Which of the student became 0.5? I don't know if you get the gist here. The thing is that when we want to divide discrete data into smaller parts, we now have all these, the decimals. And that is why I made mention that is their whole numbers, right? So for instance, if we had 3 goals, we have 3 goals. Except maybe we're talking about average goals, then we begin to round up, right? Okay, to the nearest whole number. Then for continuous variable, for continuous data, basically, continuous data refers to change we experience over time. Okay, they involve concepts that are not countable but require detailed measurement. For instance, your weight, right? You can say you are either increasing in weight or have reduced weight. Okay, you can say your height, right? You are increasing in height, and it's because it's continuous. You can say temperature, right? You can measure the temperature, and the temperatures varies, and you can have these in decimals. And definitely, since you cannot divide discrete into smaller numbers, you can definitely divide continuous data into smaller numbers. Okay. All right. So now this takes us to variables. And I'll make some relation between variables and the data we have here. But first, what are variables? You see, sometimes in the future, when we're talking about visualization, we have to visualize what the data that we have collected, find relationships between data we have collected. So in looking for those relationships, we have to convert or turn data or represent our insights in the form of charts. Those charts will form what we call visualizations. And variables are very crucial to ensuring we can deduce insights or make deductions from our analysis. So definitely it is very important that we understand what variables are in the first place. So variables are characteristics, they are attributes that can be measured, that can be counted, and whose value can vary between subjects or can vary over time. So when you look at these variables very well, the question, you begin to ask the question, what is the difference between a variable and data? Variables are made up of data. So when we see that variables are made up of data, then it takes us into classification now of variables. So how do we classify variables? So in my experience, I have decided to classify variables into the data it represents and into dependencies. For instance, we just talked about a data, and we say data can either be qualitative or quantitative. And when data is qualitative, it's either nominal or ordinal. And when data is quantitative, it's either discrete or continuous. So you can see that in some quarters, you see that they talk about variables. And when they talk about variables, you begin to hear continuous variables, you begin to hear discrete variables, ordinal variables, and nominal variables. That is why it is important to talk about the relationship between the variable and the data it's made of. However, in some situations, you will see variable discussed in their dependencies. Are variables dependent or independent? And when we go into visualization, you'll find out that it is crucial for us to understand what variable is dependent on the other, or which variable is independent of another. Because when you look at the visualization most times you see around, you'll find out that there are no classifiable comparisons, right? People just compare the chart one talks about something else, chart two talks about something else, and so on. So then there is no connection. And so what is the story you're trying to share? You realize that data being analyzed and presented as visuals need to tell a particular story. So when you begin to have different things all coming together, and you just go with the basic understanding that data visualization is just about charts, then you miss the point. So we need to actually understand what coming from these dependencies now. Now, let's look at what an independent variable is, or what independent variables are. So independent variables are predictors, right? they are not changed by other variables you may be trying to measure. For instance, as the name implies, it is independent and can exist in an independent state. For instance, now, the age of a person is not dependent on the food the person can eat. It's not dependent on nutrition. It's not dependent on weather. It's not dependent on the class the person is in school. It's not dependent on economic class. Okay. However, growth now, if you say you are measuring the level of growth, something like height, indices like height, like weight, you might find out that these are dependent on other factors. So now let's look at dependent variables. As the name implies, or as the term or the concept implies, dependent variables are variables that are dependent on other factors. Or simply put, they are the target variables. They are the target variables. Okay? They depend on other factors. Example, for instance, the test score, your test score can be a dependent variable because it is dependent, or it could change as a result of several factors. Sleep, whether you're getting the right nutrition, whether you're getting the right amount of sleep, the right amount of rest, and so on. So your test score depends on that. Okay? But now, could it be said that your test score depends on your age? It's hard to say. Wouldn't be right. Okay? So we'll be making we'll be talking about these as we progress, and we'll even be communicating more about this. Okay. Now, when we go into visualization, you begin to see, especially when we talk about dynamic visualizations or dynamic visuals, you see we will use buttons, certain buttons, and then we would definitely, for instance, now, there are some visualizations I've seen and I've corrected over time that you'll find out that when you do a filter, you find out that variables get missing. Why do they get missing? Because you are actually comparing or using two dependent or more dependent variables instead of comparing a dependent with measuring an independent, okay, with an independent variable, okay? So now this takes us to measures of central tendencies. Now we know what data is, and we know how to classify data, and we know what variables are. And we can definitely say a gender is a variable, age is a variable, class is a variable, subject is a variable. So we basically can understand all of these things. Even height, even weight, they are variables. So we can definitely understand that, okay? So now let's look at measures of central tendencies. And we have the types of central tendency includes the mean, the median, and the mode. So I will take us from here now into Microsoft Excel for us to basically do a little bit of practice here. Okay, so I connected my Microsoft Excel to a PowerPoint slide, and I can just swap along like that. So now we have this little data set here. Okay. All right, please, can you see my screen, the Excel sheet? Can you see? Somebody just give me a reaction and let me know if you can see it.
Yes, we can.
All right, beautiful. Okay, so now we have a short data set here. And this data set is made up of the different data types we've discussed about, as well as the different variables basically we discussed about. But what we want to do with this data set is just a basic example of to test what the types of central tendencies that we'll discuss. We talked about mean. So mean is the average of a given data. So because mean is the average of a given data, we definitely want to calculate the mean of the subjects we have here. Okay. So to calculate the mean of subjects, you realize that from D, column D, E, F, and G are what? Scores, subject scores. So if I am interested in calculating the average of per subject, I will definitely calculate it this way, okay? And I can just have, say, let me just have here, say average, okay? Okay, so we'll indicate the average we want to have here. So now in Microsoft Excel, I think in this introduction in statistics, that's the last time we are going to use Microsoft Excel. Then we'll transition into Python and R. Okay, so to calculate the average, we'll use the function average, and we must say equals average, okay? Then open parentheses. Now, we want to calculate the average of math score. And since we are not talking about Microsoft Excel per se, I'll just show you, you just click, hold, and drag to highlight, okay? And since we are using a table, it might not even show you exactly the range. But in this case, it is D2 to D11, okay? That is the range. So we close our parentheses because we started with an open parenthesis so that we are correct. So we have an average math score of 84. So what happens was that we added all of the scores, the 10, I think the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 10 items. We added the 10 items, right? Had a total. So let me just describe what happens now. Happened. We had, for instance, let me add it. So equals sum. I just want to add it to showcase what happened. We added first. When we added, we had a total of 840. So what average does is to say, calculate the total, divide it by the total number of occurrence, which is 10. Okay, the frequency of this is 10. So we say this divide by the frequency, which is 10. You see that it's going to give us 84. That is what happened, okay? So now that I've just put the formula for this, I can just autofill, click, hold, and drag to get the average of all of these scores. So I've gotten the average now. So that is what average and mean, they mean the same thing, okay? So now the second was median, right? So median it's represented by the middle data in a data set. That is what median is, the middle data in a data set. And before we do we talk about median, we have to reorganize these data. So to do that, I'm on this table already. You go to home, right? You come to sort and filter under editing. Okay, you can then come to custom sort. When you come to custom sort, what you want to do is to say you want to sort by what? You can decide to sort by, we want to sort by math score. So that let's just sort by math score. And we want it from smallest to largest. Okay, you see now we have, in the math score, we have smallest to largest. And we can definitely look at the median. Now, the median is just about the numbers that occur in the middle of a data set. For instance, in this case, in math, we have 10 items, right? So if you check, we have 5, right? And 5. But if you check, there is no mid, right? If you take, say, 4 and 4, that is 8. It's remaining 2. So in such situations, since there is no in an even distribution, you don't have one number that can stand as the median. That is the thing. Okay, you don't have one number that serves as a median in an even distribution. But in an odd distribution, you definitely will have one number that can stand as the median. So in a case where you don't have one number that can serve as the median, what you do is to add the two numbers that can serve as the that is fine, basically the average of the two. In this case, it will be this, because if you check this, we have 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. So the median is these two numbers, but we cannot use two numbers as median. So what we'll do, we'll just find the average or the mean of these two numbers, okay? I think, of these two. When we find that, then we have the median, which will be 84.5. So we can basically take this across to have the median of all of them because they are the same distribution. But remember, before you find the median, you definitely need to what? Order. So mode is the value that occurs the most in the presentation. So we have 70, 76, 78, 82, 84, and so basically we don't have any number that basically repeats. Okay, you have repeats. So in this case, we do not have a mode. Okay, so let us go back to our presentation and then continue. So now, another very important aspect of data analysis is understanding when you have an outlier. What is an outlier? An outlier is a single data that points, or single data points rather, that goes far outside the average value of a group statistics. Basically, in simple terms, it's just a single data point that points too far from the range that you have. Let me give you an example of outlier when we are talking about age. Let's say your study population is aged from 10 to 40, and you are having an age entered as 94. Is definitely, that number 94 is definitely an outlier because it exists outside your what? Your group statistics. But sometimes outliers, right, may be difficult to spot, especially when you have large data sets. Okay, so there are various ways you can check for outliers. Okay, let's go back to the data set. There are so many ways you can check for outliers. Okay, but the easy or the common way, or one way rather, that you can easily use is the z-test or the z-score. Okay, now utilizing the z-score, you can easily check for outliers. Okay, so let's just look at how we can use the z-score to check for outliers here. Okay, so the first is that we calculate the mean, which is the average, or let me put it mean this way. We have earlier done that. We need to calculate the standard deviation as well. Okay, we need to calculate the standard deviation. So I'm just going to add, because I need to put it, insert a row here so that I just calculate the standard deviation. So let me call it standard deviation. Okay. Now, to calculate the standard deviation for this, what we need to do, since we have calculated the mean already, what we need to do is to say equals standard day. If we are going to take the standard day for population, then we can just go ahead and select this, close our parentheses, and hit enter. So now this is your standard deviation, as simple as that. If the decimals are too many for you, we can just go ahead and reduce them by clicking here. Let's just have it this way. So we adjust with autofill so that we now have the standard deviation. Usually, you see this written in documents as the mean plus or minus the standard deviation, say 84 plus or minus 7.3 in this case. Okay, so what follows now is for us to calculate the z-score, what the test we need to use to check for our outlier. Okay. All right, so to calculate a z-score, we need to use the mean and standard deviation, right, of our data. And in this case, we have calculated the mean, right, of the math score, as well as the standard deviation, right, of the math score. Okay, so let us calculate the z-score for maths. And I'm going to show us two ways we can do that. Okay, let's use the first way. We said equals. We want to now subtract these, right? This score, right, from our mean, then divide what we have by the standard deviation. So, and because we need to do the subtraction first, we will say this score 70 here, subtracted from our mean, we close the bracket, and then say divide by our standard deviation. When we do this, we get our z-score, okay? So it's quite straightforward. So we can easily just autofill this, right, to make sure it calculates for all of these. But before we do so, we have to lock certain cells. So we have to lock the mean cell, right, as well as the standard deviation cell. So to do so, we will use the shortcut, right, F4, okay? So to lock the cell, we have to use the dollar sign before the column and the dollar sign before the row, okay? So you can either put them manually or use the shortcut on your keyboard, which is F4, okay? So we can just click, hold, and drag down, and then we have our z-score. There is quite a simpler way of calculating your z-score instead of calculating it manually. So let's go ahead and calculate the same z-score for our math score and see. So we'll use equals standardized. So the standardized function returns a normalized value from a distribution characterized by a mean and standard deviation. So now we need to put the x value. The x value here represents this math score, okay, which is at D2 currently. So we'll say comma. So after this, we need to present the mean, and we have the mean here, right? The math mean here as this. So we'll say comma again, then we present our standard deviation, which is this, okay? So we close our bracket. We hit enter, and you see we have exactly the same value. So if you are calculating this, you try to ensure that you use the formula that best suits you. You can use standardized or calculate it manually as we've done so. So for us to autofill this, we will have to lock our mean and standard deviation cells. Remember, we used F4 as a shortcut in our keyboard, okay? And hit enter, then we can click, hold, and drag to calculate it. You see, we have exactly the same values. So you can go ahead and calculate your z-score for the English score, for the science score, as well as the social studies score, okay?